Hello guys, we are back with our next lecture. In the last lecture, we discussed the concept with respect to Turing machine, right? Yes. So in this lecture, let us discuss about the halting problem, and if time permits, mostly I'll be covering linear bounded automata in this lecture only also, guys. Okay? Yes. So let us start. So basically, what do we mean by halt, guys? So in simple words, we write programs, right? And we call a term called as a termination, right? So at some point, the code will stop executing, right? Yes, so that is nothing but halting, guys. So at some time the machine will stop executing, or it will give you the output, means it will not stay in a loop. So that is nothing but halting, guys. So if a particular machine, you give an input and it is giving the output, or it is saying that for this there is no acceptance string. So if it is doing any one of them, like if it is accepting or if it is not accepting, either it might accept, it might reject. So any one of them will come under halting. But if this particular input is just roaming for infinite time, so it's just wasting its time and your machine time, right? Yes, so this is a nothing but a non-halting, guys. Got it? Yes. Okay, so any particular machine which is halting or which will give you the output whether it is accepted or not, so that comes under recursive set, guys. Okay, and which are rejected or we are in a confused state whether it is a loop or not, so those comes under the recursive enumerable set language. Okay, yes, so these are the two terms which might be asked in the question, so those are a bit important. Okay, yes, so now you understood, right? Yes, so now let us discuss about linear bounded automata, guys. Okay, and a recursive set is a subset of recursive enumerable. Okay, yes. Okay, so let us continue with the linear bounded automata. Okay, so in simple words, linear bounded automata is nothing but a Turing machine only. But in a Turing machine, if you recall, every time we are having an infinite length string, right? Like infinite length tape, right? Yes, I think I did not discuss the initial part for Turing machine, right? Yes. Okay, so let me discuss it now. Is that okay? Okay. So the Church-Turing thesis states that any algorithm procedure that can be carried out by a human being, computer can be carried out by using Turing machine. So anything which can be executed by a human can be executed by the Turing machine, guys. So the only thing with respect to Turing machine is here we are going to have an infinite tape, length of a tape. Okay, yes. When it comes to linear bounded automata, that tape is of limited length, guys. Okay, so using a Turing machine, we can add two numbers. So if we want to add two binary numbers, so 1 1 and 0 1, so we start adding them one after the other, and you are going to store data somewhere else, the result. So you are going to add them here and you will store the result at some other location in the tape. But those type of things are not possible in LBA because this tape length is limited. So that is the difference in between this LBA and Turing machine, guys. Okay, yes. So to be clear, LBA might not be in our syllabus. Okay, yes. So don't worry too much about it. Okay, yes. Okay, so you understood, right? So in simple words, whichever thing we can execute with the help of a Turing machine in a limited space. So here the example which we took, a power n, b power n, c power n. So here I used this space only, right? So I did not need any extra space to execute it. So it can be also performed using LBA. Similarly, when it comes to WCW also can be executed using LBA. But whenever we want to add two numbers, so those type of things are not possible using LBA. Okay. Yes. Okay. So now I hope everyone got a clear idea with respect to this LBA as well as halting, right? Yes. Okay. Okay. So now I hope everyone got a clear idea with respect to this. So in the next lecture, we'll be discussing about the decision properties and closure properties with respect to recursive set and recursive enumerable set, guys. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.